Imagine looking up at the night sky from the surface of Mars and witnessing a dazzling meteor shower, a cosmic light show, courtesy of a distant asteroid impact. Sounds like science fiction, right? Well, thanks to NASA's DART mission, this extraordinary event might just become a reality for the red planet in the coming years. But how did we get here? And why might Earth miss out on the celestial spectacle? Let's dive deep into the story behind this potential Martian meteor shower and explore what makes NASA's DART mission a game-changer in our efforts to protect Earth from potential asteroid threats. In the vastness of space, the prospect of a rogue asteroid hurtling toward Earth has always been a cause for concern. The impact of a massive space rock could spell disaster for our planet. The target? A small moonlet named Dimorphos, orbiting a larger asteroid called Didymos. Though neither of these space rocks posed any threat to Earth, they were perfect candidates for testing whether a high-speed impact could alter an asteroid's trajectory. And what a test it was! Traveling at a speed of 14,000 miles per hour, DART slammed into Dimorphos with the force of a small explosive, gouging out a massive crater and sending a plume of debris, or ejecta, streaming into space. This ejecta, consisting of dust, rock, and other particles, formed a cone-shaped cloud that spread outwards, leaving scientists both amazed and curious about where it might end up. But what does this all mean for Mars? And why might the red planet be in for a meteor shower in the not-so-distant future? To answer that, we need to delve into the aftermath of the DART impact and the fascinating journey of the debris ejected from Dimorphos. After the collision, a small CubeSat named LishaCube, which had hitched a ride with DART, captured stunning images of the impact and the resulting debris cloud. Scientists quickly realized that this cloud of ejecta wasn't just a fleeting phenomenon. It was on the move, influenced by the gravitational pull of various celestial bodies in our solar system. The Sun, Earth, Mars, and even the Moon all played a role in determining the fate of this debris. A team of researchers, led by Eloy Peña Asensio of the Politecnico di Milano in Italy and Michael Kupers from the European Space Agency, set out to model the trajectory of the debris. Their simulations, which tracked millions of particles of varying sizes and speeds, revealed that some of this material could eventually reach Mars. In fact, the slower-moving particles from the ejecta cloud could arrive at the red planet within 13 years of the DART impact, meaning that by 2035, Mars could experience its very own meteor shower. The faster-moving particles, on the other hand, might reach Mars even sooner, possibly within just 5 years. Now, you might be wondering, if debris from Dimorphos is on its way to Mars, could Earth be in for a meteor shower as well? The answer, surprisingly, is no, or at least it's highly unlikely. The simulations show that while some fast-moving particles could reach Earth by 2029, these particles are so tiny that they wouldn't create a visible meteor shower. Only if larger particles manage to slip through the net would we see meteors streaking across our skies. And that's something only future observations can confirm. But let's take a step back and consider the bigger picture. The DART mission isn't just about the possibility of meteor showers on Mars or Earth. It's about understanding the dynamic interactions between celestial objects and using that knowledge to safeguard our planet. When DART collided with Dimorphos, it wasn't just a scientific experiment. It was a demonstration of our growing capability to defend Earth from potentially catastrophic asteroid impacts. And this capability is more crucial than ever. Earth has a long history of being struck by asteroids and comets, with impacts ranging from small, harmless events to massive, life-altering collisions. The most famous of these is, of course, the asteroid that wiped out the dinosaurs. But even smaller asteroids can cause significant damage. In 2013, a meteor exploded over Chelyabinsk, Russia, releasing energy equivalent to 500,000 tons of TNT and injuring over 1,500 people. It was a stark reminder that we live in a cosmic shooting gallery, and while the chances of a large asteroid hitting Earth are low, the potential consequences are so severe that we can't afford to ignore them. This is where missions like DART come in. By developing and testing techniques to deflect asteroids, we're taking the first steps towards a future where we can prevent a catastrophic impact. The DART mission has shown that a kinetic impact, a high-speed collision with an asteroid, can change its orbit, even if only by a small amount. In the case of Dimorphos, the impact shortened its orbit around Didymos by about 32 minutes. While that might not sound like much, it's a significant proof of concept that opens the door to more advanced planetary defense strategies. But DART is just the beginning. Following the success of this mission, the European Space Agency, ESA, is preparing to launch the Hera mission, which will journey to the Didymos-Dimorphos system in 2024. Hera will study the aftermath of the DART impact in detail, providing valuable data on the properties of Dimorphos, the crater left by the collision, and the behavior of the debris. This information will help scientists refine their models and improve our ability to predict the outcomes of future asteroid deflection attempts. What's more, the data gathered by DART, LICIA, CUBE, and HERA could have broader implications beyond planetary defense. The study of asteroid impacts and the resulting ejecta can provide insights into the processes that shaped our solar system. By understanding how material is exchanged between planets, asteroids, comets, and other celestial objects, we can learn more about the formation and evolution of our cosmic neighborhood. This knowledge could also have practical applications. For instance, understanding the composition and behavior of asteroids is crucial for future space missions that aim to mine these bodies for valuable resources. Asteroids are rich in metals, water, and other materials that could be used to support human exploration of space, or even be brought back to Earth. The DART mission and its successors are laying the groundwork for a future where humanity not only defends itself from asteroid impacts, but also harnesses the resources of these ancient space rocks. So what does the future hold? Will we one day see a meteor shower on Mars, thanks to the DART mission? The simulations suggest it's a real possibility, but there are still many uncertainties. The trajectory of the debris is influenced by a multitude of factors, from the gravitational pull of planets to the radiation pressure from the sun. As our models improve and we gather more data, we'll get a clearer picture of what to expect. And who knows, maybe one day, a Mars rover will capture images of meteors streaking across the Martian sky, a silent testament to a bold experiment conducted millions of miles away. In the meantime, the success of the DART mission is a reminder of humanity's growing ability to shape the future of our planet and our solar system. From deflecting asteroids to exploring the farthest reaches of space, we are beginning to unlock the secrets of the universe and take control of our destiny among the stars. And while Earth might miss out on a meteor shower this time, the lessons learned from DART will help ensure that our planet remains safe from future threats, so that we can continue to look up at the night sky with wonder rather than fear. And there you have it, a deep dive into the fascinating potential consequences of NASA's DART mission, from the possibility of a meteor shower on Mars to the future of planetary defense. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon to stay updated on all things space and science. Thanks for watching, and keep looking up.